This question is about a metropolitan area council planning a new town and the location of a new toxic waste dump. A metropolitan area in a country is modeled as a square. The area has 4 towns located at the corners of the square. All units are in kilometers, with the x-coordinate representing the distance east and the y-coordinate representing the distance north from the origin at 0, 0. And there are 4 towns represented by points with coordinates E with coordinates 0, 40, F with 40, 40, G 40, 0, and H 0, 0. And question A, the model assumes that each town is positioned at a single point. Describe possible circumstances in which this modeling assumption is reasonable. 1 mark. So it is reasonable when the size of each town is small in comparison with the distance between towns, or the center of the town is at a point, or represented at a point. And question B, sketch a Voronoi diagram showing the regions within the metropolitan area that are closest to each town. 1 mark. So it's quite easy, just using perpendicular bisectors. And it looks like this. And it's the required Voronoi diagram. I delete it. The next. The Metropolitan Area Council decides to build a new town called I, located at the point I with coordinates 30, 20. So it's somewhere here. And a new Voronoi diagram is to be created to include I. The equation of the perpendicular bisector of I, E, is this one. It's a line which is perpendicular to EI and passes through the midpoint between E and I. And Y is 3 over 2x plus 15 over 2. And question CI. Find the equation of the perpendicular bisector of IF, this line. Since it is perpendicular to the line through IF, and if we know gradient of IF, our gradient becomes what? Or is negative reciprocal. And then to find we need a point, and since our line passes through the midpoint between I and F, we need coordinates over midpoint, and then using coordinates over midpoint we can find the unknown C, or in the equation of a line. So we need gradient of I of the line through IF firstly, and formula is given in data booklet. It's rise over run of y2 minus y1 over x2 minus x1. So f it's 40 40 minus minus, and I is 20 for y, 30 for x, and you can see it's what? It's 20 over 10, so it's 2. So our gradient is negative reciprocal, so it's negative a half x plus c, and to find c we need point, and we use midpoint. Midpoint just plus and divide by 2, so 40 plus 30, 70 over 2, and 40 plus 20, 60 over 2, 30. Substituting for y for x, or you may use equation of a line like this. So it's this: y1 is 30, x1 is 35, m its gradient is negative a half. I substitute 30 for y, 35 for x, and it's what, 60 over 2, and you can see that C is 95 over 2. over 2. The next, given that the coordinates of one vertex of the new Voronoi diagram are 20 and 37.5, find the coordinates of the other two vertices within the metropolitan area for marks, and then sketch this new Voronoi diagram showing the regions within the metropolitan area which are closest to each town, 2 marks. So definitely you can consider all perpendicular bisectors and find points of intersection, but you can notice that towns are or points are symmetrical. You can see that F and G are symmetrical about I, and one vertex is at 20, 35, 35.5, and it's a point of intersection of what? Of perpendicular bisector between I and F, and also between I and E. But due to symmetry, if we find perpendicular bisector of IG, point or this vertex, its point of intersection of this bisector and this bisector between H and I, and again due to symmetry, this vertex, it will be on the line in the middle. It's on the line y is 20, and since this point is 20, 37.5, this becomes 20 and 2.5, and actually we get the required Voronoi diagram. We need up to 40, and up to 40. So vertical lines here up to 40. Extensions are acceptable but not required, because our area is a square 40 by 40. So the required Voronoi diagram looks like this. And we need the coordinates of other vertices. So other vertices are 20 and 2.5, and we need this vertex, and it can be found as simultaneous equations or point of intersection between what lines? Y is 20, this horizontal line, and this bisector of EI. Where is it? EI is this. Y is 3 over 2x plus 15 over 2. So we get that 3 over 2x plus 15 over 2 is 20, and multiplying by 2, you can see that x is what? 25 over 3. It's 25 over 3, and y is 20. 25 over 3 and 20. The next, the metropolitan area is divided into districts based on the Voronoi regions found in C. And question D, a car departs from a point due north of H, somewhere here. It travels due east at constant speed to a destination point due north of G, so to some point on this line. It passes through the E, I, and F districts. The car spends 30% of the travel time in the I district. Find the distance between G and the car's destination point, 4 marks. Distance between G, or actually since it passes through 3 regions or districts, it goes, or it's a horizontal line which looks like this, and starting point is somewhere here, and the end point is somewhere here, and actually this y is required. And since its origin y is 0, so y coordinate it becomes this distance which is required. And it is given that the car spends 30% of time in I district, but since it is moving its constant speed, it means what, that the distance from x1 to x2 is 30% of the total distance, and total distance is 40 because it's coordinate of 0, this coordinate of 40, so distance traveled is 40, and 30% the 30% of 40 is 12, and hence this 12 is x2 minus x1, but x2 it's a point, or x2 corresponds a point on the line which is a perpendicular bisector of IF. Where is it? IF is this line, and x IF, x, how to find x, to the left and multiplying by 2, so x becomes 95 minus 2y, and it's actually x2, and x1 belongs to this line which is perpendicular bisector of EI is this one, and it becomes what, 2 over 3y minus 5, and hence x2 minus x1 becomes 95 minus 2y minus 2 over 3y plus 5 is 12, and it's negative 8 over 3y is negative 88, so y is what, 33, hence the required distance is 33 kilometers. The next, a toxic waste dump needs to be located within the metropolitan area. The council wants to locate it as far as possible from the nearest town. And question EI, find the location of the toxic waste dump given that this location is not on the edge of the metropolitan area, 4 marks. So to be as far as possible from the nearest town, it must be at the vertex somewhere. And again, due to symmetry, if we consider this vertex, so this vertex, there will be what, same distances to the nearest towns. And if we consider this vertex, there are same distances from H to this, from G and from I, and same due to symmetry from this vertex to E, to F, and to I. And we can find this distance, and we can consider for example H and this point, and consider formula distance between 2 points, and it says that distance is square root x minus x squared plus y minus y squared. So since H is 0, 0, it becomes just 20 squared minus plus 2.5 squared, and it's what, root of 406.25. Yes, it's correct, and it's for 20 point for vertices with coordinates 20 and 2.5 and 37.5, and for 25 over 3 and 20, it becomes, distance becomes root of again all the same 20 squared plus 25 over 3 squared. Definitely it's 8 point something and it's larger than 2.5, but let's calculate. So it's 20, we can represent as a decimal, 25 over 3, then squared and plus 400, so it's approximately 469, and hence we can conclude that it must be at, so at, or hence at 25 over 3 and 20 at the vertex, so that distance to the nearest town is the largest. The next, I make one possible criticism of the council's choice of location, 1 mark. So we can say that a decision does not take into account the different population densities, or closer to a city will reduce travel time or help employees, or it is closer to some cities than others. The next, F, the toxic waste dump T is connected to the towns via a system of sewers. The connections are represented in the following matrix M, where the order of rows and columns is E, F, G, H, I, T. A leak occurs from the toxic waste dump and travels, it means at T, and travels through their sewers. The pollution takes 1 day to travel between locations that are directly connected. The digit 1 in M represents a direct connection. The values of 1 in the leading diagonal, it means this, of M, means that once a location is polluted, it will stay polluted. And question I, find which town is last to be polluted, justify your answer, 3 marks. And the next, actually write down the number of days it takes for the pollution to reach the last town. And the first method is just to draw a graph, and this matrix represents an adjacency matrix, and it looks like this. So we can see the E, F, G, H, I, and T, and we can see from E to G, from E to G, from E to H, E to H, from F to T, FT, then from G to I, G to I, then from H to T, from T to I, from T, from, it's I, it's from I to I, and it's all, from I to G, yes, and from T, so th, it's already drawn. Th, yes. So, and find which town is last to be polluted and number of days, and it starts at T because it's our starting point, and you can see that F in 1 day, and you can see 1, 2, 3, 4, it's the last town to be polluted, it's I, and after 4 days, because 1 H represents 1 day, so, and 4 days, so it's I, and in 4 days. Another method to consider powers of a matrix, and in general this matrix to the power of n, and first of all, how to read it, we should read from to, for example, from T to our towns, we should consider the last row, and to the power of n in general, it, what does it mean? It means number of ways to travel from 2 in n steps. One step, it means 1 edge, and if we consider this matrix squared and the last row, you can see 0. 0 represents what? That there is unpolluted town. It hasn't reached some town from T, the last row, and squared, it means what? In 2 days, 2 steps, 2 days after, and cubed, it's what? After 3 days, because in 3 steps, and the last row, you can see that 1 0, 1 0, 1 2 3 4 5, 1 2 3 4 5, it's I, and I is still not polluted after 3 days. And if you consider a to the power of 4 is after 4 days, and the last row, you can see no zeros and I with 1, so it means one way from T to I, and no zeros, and since it's the first for I, because for the previous it was 0, so the last town to be polluted, it's I, and since matrix is to the power of 4, it's after 4 days. And the next, a soil inspector needs to plan the shortest possible route through each of the connections between different locations. Determine an appropriate start point and an appropriate end point of the inspection route. Note that the fact that each location is connected to itself does not correspond to a sewer that needs to be inspected to mark. So it's about what? It's about an Eulerian trail to visit all edges once, and starting point, it's one point, and the end point is another. And we remember that we can do that if we start at a vertex with odd degree, and the end vertex is also with of odd degree, and of odd degree you can see it's F because it's a 1 and I. So a possible route is, or we can write that we need start and the start and end at odd vertex, hence from I to F, or from F to I, and it's clear what this route actually is. You can see it's like this, or like this. And that's all for this question.